the bone. We should put the frame, circular frame, for correction of this translational deformity progressively, not acute correction, but progressive correction. And we step by step, we pre-build this frame, build the frame and the system for translation. Okay? I will sit here because I'm more comfortable, because the operation room don't permit us to keep up the table. And for me, this table is a bit low. Okay. The first step that we do, like we prepare yesterday, we prepare two systems, one proximal with two rings and another distal with two rings here. And after that, we connect them for correction. We use the normal threaded rod. Okay, in this case, we do connection with the proximal two rings with the rod 150. We put them like usually, maybe we do like this. We do internal, and we put it in the fifth hole, okay? Oops. It is symmetrical connection. One here. One here. It is an internal line of the ring, in the way they don't give us any disturb. Fifth hole, okay. There's two anterior rod. Okay. Rotate, and we put another two rods posterior, always in the same line, fifth hole. It's not a fixed position. You may choose it how you want to distribute, but usually we try to distribute equally, distance it one to another. We put it usually in the fourth hole, in the fifth hole. Less frequently in the sixth. Okay, when we build it, we tighten it now. The wrenches. Okay. It became stable. Okay. This is the proximal part, like you see here. We prepare another one, system for the distal part, the same principle, but we build it here because we have this system for fixation. Do it the same way, fifth hole, in the way they're overlapping, and we may use another holes for the system for translation and wire and half-pin fixations. Okay, here. Oh. Fifth hole. Oops. Okay. This system you may prepare before, or you may do it slowly to do one, and after that to mount in another one. Okay. Yes, I add another rods later because this system don't permit me rotate. We prepare it later. Okay, what we do now, we start to apply the proximal system. Again, the regular one that I use always, I put this bolt, connecting bolts, exactly in the level of the patella. We design the patella. We see now the patient supine, patella looking exactly to the zero, to the zenith, and we start to prepare our frame. With the first wire we put, it will be in the proximal tibia. Okay, thank you. Okay. Like this. Like this. It's okay. Sorry, there you go. Okay. Let's see this way. Okay, this wire goes perpendicular to the proximal part of the tibia, and we start attaching this with the bolt. We keep it like this, realign it. Okay, like yesterday I explained you, the anterior part of the ring it will be near of the bone and posterior more displaced because of the muscles, posterior volume of posterior muscles. Okay, like this. Okay, we tie this. Cut the tip because it's dangerous. Always remember to cut it in the beginning. And when you fix it, the wire, bend it. Put in attention. Okay. Now the ring is realigned. You see, now we should put another wire to fix it distal part of the proximal fragment. In this way, we should use the olive wire, olive, because like you understand, we should do translation this way, and we should have a pushing forces in the proximal part from the medial side. And what I do, I put the wire from this side, from medial to lateral. It will be quite in the sagittal plane. It may be a little bit oblique, but it's important that the wire pushing really good on the medial cortex of the tibia. We should do many exercises to put in the wires exactly parallel to the ring. It's not easy in the beginning, but slowly with experience, you do this job. Because if the wire don't touch the ring, you should put the washers. Now we are fortunate people and we put it exactly at the level of the ring. Okay. fix it. We fix it, the wire at the side of olive. Here. Okay, better remember to cut off the tip, better always, because it's dangerous. And we put in attention this olive wire. Si rompe. Si è spostato. No, perché è scivolato tutto. Okay. The patient is not stable. Okay, now we have a good fixation here. The patient wants to escape, but I should fix him. Okay. Now, this system became just a little bit fixed, but not stable. We should improve stability, really good. What we do, we put maybe another wire on the proximal ring, like this, crossed wire. Obviously, remember about fibula, because if the fibula displaces it too, or there is some kind of deformity, always better fix it the fibula too. Now we fix only tibia. Perfect. Cut the tip. Okay, this is smooth wire, there is no olive here, and we may do tension from one side or another side, there is no difference. Only with the olive wire, we always should do tension to the opposite side of the olive. Okay, do the tension. It moves too much. Okay, we do like this. Okay, fix it. Okay, now because we do too much movement and our patient escaped from the operation table. But now we'll start fixing better this way. Okay. Okay, now we do another movement. What we may do? We may do this two ways, or we fix it now the system for distal fragment and connect them. In this way you may understand how we build the frame independently of how the rings mounting. Okay, we do like this. We start with the distal ring, one wire. Got the tip always, because yesterday we have. Okay, remember that the level of the rings should be in the equal, like this. You see, it's only displacement. When we study the patient, we realize that the deformity only in the sagittal plane, and we should do exactly movement of translation in this plane. And the anterior border of the bone and obviously the ring should be in the equal position, equal height. Okay, we do this amount of translation like we see in X-ray. If you want, you may control it by radiologically, but it's not important. Clinically, the same precise calculation. We see it in another thing that, like we do it, do correction progressively. We don't need to do so precise position because we do control anytime we do clinical visit of the patient, we do control of X-ray, and we do it progressively. Okay, now put this. Tension. Okay, good tension of the wire. Okay, you see that like our frame start to repeat the position of the bone. We use now again another olive wire because you see that. Okay. Because we need to push the bone in this direction from here, from the lateral side, and we need to have good and just bend it a little bit of wire, but not important. If you want, don't bend it. You may do like this, just a little bit release the rod, and the wire will be exactly straight. Okay. We fixed the part of olive. This is a lateral olive. Here. Oh, maybe. Okay, fix it. Part of olive on this side. And we tighten it. always tighten really good the wire, because like I explained you, this is much important thing in all this system, that we should do it maximum as possible, because if you don't do it too good, it will be losing of stability, and if the frame lose stability, it means infection, painful frame, patient unhappy, and the result of the treatment compromised. More stable frame, better is for everybody, for the patient, for the doctor too. This job do my assistant. Okay. Because assistant stay in another part of the bone of the table. She do the tension. Okay, control again the bolt if it is tightened good. Okay, exactly. Really good. And now, to prevent trauma, professional trauma, we bend all the wire. This is nice instrument. We bend it easy, 3-step, like I said, with 70 degrees, 100, 70, 100, inside. Because this wire should be inside of the ring. Okay, you see, this professional trauma. And never touch the dresses of the patient, or never produce the trauma of the patient. This way, if you put it inside, nothing happens. Thank you. Okay. Now, it is only how to say, really light frame again. Now we put another wire on the distal ring. In this way, it became much more stable. And we go later to the more interesting part of our job. We should create the system for translation. Now we do like this. We put another wire. This. Always better to choose the hole that we want to catch. I try to arrive to touching this hole like I did now. I choose the hole, then I put the wire here. If you have any difficulties to put the nut, you may use the special nut with the round part. Dato quadrato. Okay, this is comfortable nut, high, and for this reason you may use it when there is another rod near of this. You fix it. Fix here. Okay, we cut here, and because we fix it, now we change here. you. Okay, this system for translation that we show now, this is maybe used for the reduction of this translational deformity, maybe malunion, but more frequently I think we may use it in the equal system, the same system, when we should realign, for example, docking site, when we do bone transport, and we need to reduce the docking and reduce the translation of the proximal and distal fragment that should meet in a good position. We use the same system. And this system may be built independently at the time of the treatment. It may be built in the beginning of the treatment if you have only translation deformity, or maybe build this system for the translation during the treatment. You may do it absolutely normal in half an hour in your clinic, change the system and achieve this translation progressively in the clinic without any surgery. How we do this? In this case we use the post. I will use now the two-hole post for doing this system, and we should build it now at the level of the translation. What we do, I compose one system anteriorly, like this. I put the post in the sagittal plane, one here, another here, symmetrically. One second only, we need to see. No, this way we do like this now, because we have not too much space between the ring, and I decide to change. I put not two holes, but one hole post, one hole post, this and this. We need 4, okay? Okay. Okay, we use this because we have not so much space between two rings, and we use this one hole post because it's a little bit low. And it's better because it's now we'll see that it's exactly at the level of the translation. Like this. Okay. We choose the distance, we choose the rod that we may use it. In this case, we use this 120 rods. Okay. Like this. Perfect. We rotate this, it will be near. Okay. In the middle of this rod, what I put? I may put or cube one hole like this. It's comfortable because it's shifting good. I use this. Okay. It will be this cube. Will be this cube. We use it for half pin fixator. You may use this system. Maybe we choose one on another. We may use the female post, another system. At the equal. Later. Okay, another system. It is a system with a female post like this. And we may do one and another. The first we do with this cube. Cube is a little bit more comfortable because it's bigger and the shifting of this system is easier. What we do, we put here. Here. Okay, we fix it. Like this. Like this. Because this is more secure, because if there is a system where they put in one road, another road in one system to translate, but in this way it became much more stable. What should I do? I need to program on translation. Like you understand, our distal system should move in this direction, like this. That means this cube should shift in from here to here. For this reason, I leave more space for translation in this lateral space. Okay. After that, what I do, I should connect this system to the proximal ring, proximal two rings, and I connect them with another female post in the road, like this. I put it inside here. Another nut. Like this. We calculate. It should be put in the right position. Now, I don't know if you see under this, we have a little bit of space, and we should put the washer. Like this. I put the washer between the cube and my rod. And we put here the bolt. The length of the bolt will be, we may choose, depending on the distance we have, maybe 10 millimeters, 12, or 16. Not go. No. No. I don't know why it's no good. Okay. No, better. No vuole entrare. Okay. We use a small washer. Because we used this cube previously, and now it's difficult to attach it. Okay, try like this. Rondella. Okay. Okay, it's easy. Because we used this cube previously yesterday many times, and the threaded part of the cube a little bit consumed. It's normal. Okay, now we attach like this. And now this is a anterior part of our translation system. We build it. Now, I think it will be difficult for you to understand it. And what we do, we rotate our frame because we should build the same translation system posteriorly. We rotate it like this. Okay, yes, I think it's okay. We try to do this. Another, no, oh, we do like this. Keep it, another. You rotate this. Okay, it will be, I hope you see it, okay. We fix it now here. Okay, I hope you see it. Because we rotate the patient, but it was only for showing you. Obviously, in operation room we don't do this, but it's only for show you the mounting of this system. Obviously, in operation room I keep it a little bit higher, my patient, and I build my frame. Okay. All system fixed. And now we should do the same precision posteriorly. What I do the distal system. Here there is no element of fixing the wires, and the usually posterior part is much more freedom for building the frame here. Okay, we put this. The same distance, I put it in the fourth hole, and now we connect it with the threaded rod, 120. In this case, like I showed you before, we will use this one with the female post. It is the same principle and the same, how to say it, mechanical adjustment, only maybe to be more comfortable for distraction. I put here one washer because I should work with these two nuts, and this wash permits me to arrive easier within ranges for translation. Okay, I took here, I put here. Do you see this system? Okay, it's like this. Like this. Fix it. All this stuff. Okay. Yeah, this is horizontal rod, and now we should connect it. Like I said you before, we need to have more space from other part, and this space we create in the lateral direction, like down. Okay, we rotate the female like this, and all right, grazie. Perfect. Grazie. Thanks, Iranian healthcare. Okay, now we put another rod. one female again. Okay. Connection, like we did before. And we connect it to the proximal system. You should adjust it like it's comfortable for you. You choose the hole when you want to put it here. More you do laterally, better is, because you have much more space to translation. Okay. We adjust the system. Yes, I need a little bit small spacer again, maybe one washer. Small bolt, short bolt. Okay. Put inside. Okay. Tie this. Okay. Do you see this? I don't know if it focuses okay. I hope you see it good. That is the equal system like we did anteriorly. Maybe, okay. Yes, you see it lateral view. Perfect. But now it's rotated. We do oppositely. We position the patient in his physiological position, and this is our frame. Lateral, you see the two rods parallel, because they should do the translation only in the sagittal plane. And this system permits me translation. But this is a two rods, like you see, it's not enough because there is this kind of movement in varus valgus. We need to have another system that prevents this movement. What I do another system for the third rod we should put here. Now I adjust this. The patient more stable when I fix it. Fix him like this. Okay. And we do another system, small rod again for translation. And how we do this? We use again one male or female, one hole, the same level, like this. It will be plus minus in the middle between two rods that we put in before, like this. What we do now? We do like this, one post like this. You should always control the good realignment of the rods because they should be parallel. If they're not parallel, they don't move. We take another one. Female. You, with the X-ray, before surgery or during treatment with the docking site, you realize how much translation you have. In this case, it is plus minus maybe 14 millimeters, because the range is 10, it would more 14 millimeters. And you should have the system for translation minimum 14, but better to have more, maybe maximum 2, because there is elasticity of the wires, there is elasticity of this whole system. You should have the space for minimum 2 centimeters of translation. Okay, what I do, I should do this system for translation. I choose now 6 centimeter rod, because it's not so big, but it's enough my amount of translation. We don't need to do 3 centimeters of translation, only 2. I put this rod. You remember that maybe we use a washer too for comfortable of the patient, because this manipulation should be done by the patient. Slowly, slowly, like lengthening, and the same principle for translation. Okay, we position this rod exactly parallel to previous rod, looking like this way. Okay, and after that, we create the system for translation. How I do this? I do like this. I attach this rod, put in the nut. This way it is realigned. All system fix it. Fix it. I create as much as possible the space for translation. Okay, I see this in lateral view. It is a perpendicular to the rod. And now the last step we do, we put the plate here, and the plate that we put, we may choose from our set. We have different lengths of the plate. In this case, it's not so long. It's enough 3-hole plate, for example. Take it, rotate it, and I attach it here with a bolt. Okay, another knot. Okay, everything should be tightened. Only system for translation will work, other things don't work. One. We do, because for translation we should do just a little bit of distraction. Maybe in the beginning we do distraction, now we fix it like this. Okay, this is pure translational system. Now I think it will be better again. We do a little bit more fixation of the tibia, because this system should be really strong. And for keep it strong, we put another 2/2 pin here in the middle. One here, another here. If you agree with me, if you don't want to do it, we don't do it. This cube, I don't know. Okay, we put the small bolt. This helpful for fixation. Okay. Half pin. To cortex always. Another one. Oh, put another one. Oh, this we use this.
Okay. And,
short one. Yeah. Okay, fix it. Okay, this frame became really stable now because we have olive wire and we have half pin here. There is should be no displacement, and our translation will be in direction how we want. Okay. If you like it, we may proceed with the translation. Other things I may say here, if you permits me, because we may to do another modification, small modification here, because in the system of translation, this lateral one, we may create the system that permits us to do just a little bit of correction of the angular deformity. What I do, I change this system here. Okay, because I want to create one more hinge for correction here. I leave this rod. I put the female post here. Small bolt again, which I need. Short bolt 10 millimeters, please. 10 millimeter. Oops. Okay. Okay, control always, that should be realigned how we want. Should be parallel of the two rods here. We adjust the plate. With this. Okay, this is a small modification of this system, but I want to show you because it permits you to do a little bit of angulation correction too, simultaneously. Okay. Okay, this was the same. Okay, stay firmly, don't move. Okay, now the system is ready. What we do, we remove the plate, we create the osteotomy. Osteotomy if it is malunion, or like I said, if it is a docking site, or it's my realignment during lengthening, and you want to adjust it. it is possible to do the same system that we built here. This system permits to do a big amount of translation. It's really stable, like you see here. Physically you see it, and if you want, I will show you now when we disattach the plate. Okay, now we disattach it, everything. Now our docking sides are free completely, and what you see now, the frame really stable. Now the fracture is free, but I try to move the system, nothing moves. It means the system really stable. And what we do now, we should correct the deformity. How would we do this? The first thing, it's important that the bond is not touched at each other. For this reason, probably in the beginning, if you don't have any space, it's better to do just a little bit of distraction and a little bit anterior. We have this rod that permits to do this distraction. Posterior rod, the same. We do a little bit of distraction. And this way the bone is not touched more each other. The fragments is disattached. The same distraction we may do on this rod, this lateral rod, just a little bit. In this way, the rings maintain parallel position. And what we do now? And now we do the translation. How we do this manipulation? Usually we teach the patient how to do the torsion. We put them the plaster with the arrow, and the patient do this correction with this arrow. What I do, I take some kind of piece of plaster. I put it here. So this way we need to plaster. One piece. I put here in this area. I design the arrow in the direction of the torsion, and the patient do it at home 4 times a day. How we do this? How we proceed? We should release this nut. Okay, this one, and turn this one. Slowly, slowly, 4 times a day, 1 millimeter per day. It means that this translation we may achieve slowly, slowly in 2 weeks. Now I do it slowly, slowly for each rod. It should be done. Anterior rod, posterior rod, the same. We release one nut, and we turn another one. And the same, the third rod, we release one rod, nut here. No. We don't have space here. No. No, it's okay. It's okay. We release here. And we should turn this nut. Slowly, slowly, like I show you quickly now, because we need to have a result, immediate result. But usually you do it slowly, slowly. At home, the patient turns the nut. slowly, slowly. Again. And again. And you see the bone realigned more and more. Again, here. Continue this road. Continue this road. Again, posterior. All this system works simultaneously. It is powerful enough, this system, for translation. You see? Our system slowly, slowly realign it. Just a few millimeters we need. Okay, and this small rod the same. We release the nut, we turn it. It should be done exactly in this level, because if you release this one, attach it here, the rod may change direction. This rod tightened, and for this reason, the patient don't lose the length, and we don't lose the length of the bone. Only here you may do it. Okay, we continue just a little bit. You see, slowly, slowly, now you dose it really good. You do X-ray control to the patient after 2 weeks. And like you see here, 2 weeks, patient returning back to you. You do radiological control, and the bone perfectly realigned. Okay. Perfect. More than this we can do. We don't need to do more than this, because it's perfect. And this is the result. Like you see, the frame remains always stable, no movement, nothing happened here. Yeah, this is maybe lateral view. You see the system is realigned. There is maybe a little bit of translation, but it was not only calculated but it's only 1 millimeter. If you want to do this adjustment here, what we may do, we may put here one more washer, or change the position here, and we adjust this translation, but it is absolutely normal. 1 millimeter, 2 millimeters, difficult to understand. Another thing that we may do with this frame, like I explained you before, if you have any small deviation in varus valgus, we have a virtual hinge, anterior hinge and posterior hinge, and I create another one here, like when I do the changing of this small translation system, I create another hinge here in the level of the small rods. What we may do, we may do correction by this rod, lateral one. We release the hinges here, here, and here. And this permits me to do adjustment of varus valgus. You see, because my hinge exactly at the level of osteotomy. What I do, I may do this kind of deviation. I may do correction of varus, I may do correction of valgus. And there is system that permits to do this without any translation. The system became universal. You may do correction of varus valgus, and you may do simultaneously correction of translation, or to do it step by step. One time you finish translation, you may adjust the deviation in varus or valgus. I hope you see it good, you understand it. This is our system for translational deformity correction progressively. Any question? I hope you understand everything. It's easy and fast. Questions? If there is a question, I hope there is. What do you think about this? If you understand, obviously it's not immediately to build this frame, but it's not so difficult. If you start to do it one time, you do this, you know how to do. It's not so complicated. It's important to have enough space between the rings to create it. But like you see here, there's a narrow space between these two rings, second and third, and we create this system without any problem, mechanical or constructive problem with our system. It's like a mechano. We play this, we build anything we want for correction of deformity or translation. Questions? Mm-hmm.